Luke Barnes, welcome to the show.
Thanks for having me.
I should note also that this YouTube channel, is also a podcast called Uncertainty on Spotify. Many more people watch the YouTube channel than listen to the podcast because they don't know about it. I've never told you. So here it is. So, Luke, I wanted to talk about the fine-tuning argument, of course, but I also would first like to discuss broader issues in cosmology, because you have written a semi-popular book on the fine-tuning argument, but also on cosmology more generally and the Big Bang model and whether or not the universe had a beginning. So the first very general, open-ended question I have for you is, do you think that empirical evidence indicates the universe began to exist? Why or why not?
Sorry, you just cut out for a second there. The evidence that the universe began to exist is nowhere near a proof. Let me just start with that. Let's just all lower our expectations. As with most things in science, it can't be a proof. So the question is, given that we're not observing it directly, there's not going to be a direct, we actually see the beginning of the universe or something like that. If we're going to say, look, the universe probably had a beginning or probably didn't, or if we're going to answer that question, we need to ask some sort of physical theory about the universe. Right? We're going to have to do our physics right. We're going to have to do our theory. We're going to have to find out some way we think the universe is sort of well put together and well understood, and then ask that theory, does the universe have a beginning or not? And the best theory of the universe as a whole, of the force of gravity, of space and time that we have at the moment, is called general relativity, Einstein's theory of gravity. If you ask that theory whether the universe had a beginning, the answer's probably yes, because there are these very general theorems called singularity theorems that say under very general circumstances, you have a universe where it has a beginning in the sense that whatever the beginning looks like, if you have a clock here today, it could only possibly have ticked a finite number of times. That's a useful definition. So the problem then is, okay, that's great. General relativity says probably. There are a few get-out clauses in the in those theorems, because you don't just get the universe for free by sitting on an armchair. And the question is whether our universe goes through the loopholes, and then the question of whether there's some theory deeper or better than Einstein's theory that might replace it later on and give a different answer. So especially for that second question, there's an entire another set of theories in physics called quantum theories, which are mostly about the small stuff, or mostly been applied to the small stuff, to be more precise. But we think that there must be some grand, general theory of everything. There must be some way of describing, rather than having this theory for stuff over here and that theory for stuff over here, one theory that explains everything. And the question of how much of what we know about general relativity and how much of what we know about quantum mechanics will still be there in that final theory. And no one really knows because we don't have it. So this is where we're at. We have some very, very interesting clues. We have a sort of a century of efforts to try to get rid of the beginning, and a beginning keeping on turning up. It's not the case that anyone tried to put a beginning into their idea of the universe. It just kept being found there. But there are still these interesting loopholes and alternative possibilities that sort of pull us back from anything, like the kind of certainty you could get from science. It's not mathematical proof, but it can, do useful things. But that's roughly where we're at the moment. I think the evidence is pretty good, but that's as far as I'd go with that.
So let me press you on what you mean by that. I agree with you that we can't have certainty given any level of empirical evidence, but do you think it's more likely than not, given the evidence that the universe had a beginning?
Yeah.
Okay.
I think it's more likely than not, but a lot of that depends on, what you think is going to happen outside. I mean, so the answer is just out of reach, in the shadows. What's going to happen when we, light up the darkness? What do we think is going to be there? So it is the bit of a guess. For me, the fact that no one was expecting a beginning. No one sort of wanted a beginning. No one tried to put a beginning in their model, but it just keeps coming back. That for me is a bit of a persistent clue that these, this our universe has all the sort of signatures of it looks as much as a universe can look like having a beginning. So that's an interesting set of clues for me. But yeah, more probable than not is about as much as I'd say.
I see. So let me press in on this idea that we don't have a unified quantum theory of gravity. And it's my understanding that will obviously be important in reconstructing the universe at its very initial stages. But that's obviously the crucial aspect, right? That's when the universe would have begun to exist. And if we don't have the theory that illuminates that time period, then how do we know that we can extrapolate our current models back to an actual beginning when a different kind of physics would be relevant in the first place? I mean, shouldn't we just be agnostic?
So, I mean, we shouldn't be certain, but I think agnosticism, again, there's more than nothing that we can say about this. So it's entirely possible that so the only theory we have of the universe where it's up for grabs whether the universe has a beginning or not, which is the actual theory of space and time, where it's possible to say, look, it could have been infinitely old, but actually it turned out on the evidence to be finitely old. That's general relativity in terms of the theories we have. So what quantum mechanics says into that, we don't know. There are these people who say things like the quantum eternity theorem.
I was just going to ask you about Sean Carroll's citation
old.
of the quantum of that theorem, the quantum eternity theorem.
As far as I can tell, it's nothing. It's when you have a time axis in quantum mechanics, you just assume that it's the ordinary, that it's the number line, that it just goes from t equals minus infinity to infinity. Like it's a starting assumption. You can't say you discovered within quantum mechanics that that universe is like, it's just a starting assumption. I mean, it's the same as the fact that at the time in Newtonian mechanics, you just assume it goes from minus infinity to infinity because that's the simplest mathematical, one-dimensional, it's the real line. It's just the simplest mathematical object to get on with doing things. But there's it couldn't have been otherwise. So I don't think that doesn't seem to be evidence at all.
Yeah, I have always found that a strange point to make, and I don't understand quantum mechanics, but to me, what the theorem indicates is that nothing in quantum mechanics itself demands that there be a t equals 0. But that's not the same thing as saying that quantum mechanics demands that there is not a t equals 0. It's just saying it's compatible with an eternal timeline. Is that the right interpretation to draw?
Yeah, I mean, I think so. Just because quantum mechanics, it's not a theory about space and time. It's a theory about things that happen in space and time. So you start, the structure of space and time is an assumption you bring into the theory. Whereas in general relativity, it's not. You start with our observations and you infer things about space and time. You actually, that's part of the model. And so the fact that, it was up for grabs, finite, infinite, and a lot of the clues went towards finite. The singularity theorem's just the standard model. That's just that's an interesting thing because it could have gone either way and it went the way of finite. Whereas this other theory where you just assume it's infinite from the start because that's the simplest mathematical thing. I mean that just doesn't have much weight to me as far as I can tell. Maybe I'm misunderstanding the theorem, to be perfectly honest, but I just don't see how there's much weight in that.
Same, but I'm good with running with that for now until I suppose I speak with Sean Carroll. But there have been, and I know you know this, a plethora of non-standard models of the universe that have been offered to reconstruct an eternal timeline, to avoid a beginning of the universe, or whatever their motivation, they have that result. What do we make of this huge family of models? Obviously, their mere existence doesn't mean they're correct or as evidentially supported as the standard model. But insofar as at least some of them are not ruled out by our empirical evidence, how is it that we can say that those models are incorrect? Specifically, I want to get your comment on one specific one, continuing on Sean Carroll, the Carroll-Chen model. It came up in the debate with William Lane Craig that he had in 2014, and I always found it quite interesting. I'm not even going to pretend to summarize it. If you're aware of what it is, I want to get your take on it. If you could tell us what it is and what you think about it. But it has the implication, apparently, that the universe is eternal.
Yeah, so what's interesting to me is that you have the difference between a theorem and a model. So you have a theory like Einstein's theory of general relativity, which doesn't tell you the way the universe is. What the equation tells you is a relationship between the space and time in the universe and the matter and energy contents of the universe. So given that the universe is made of this, its space and time will do that. So there's that famous saying by John Wheeler, which I will hopefully get correct. It goes something a bit like, space tells matter how to move and matter tells space how to curve. So it's about that relationship. It doesn't tell you what the universe is actually like. So, all right, which there are models within general relativity of infinitely old universes. There are models in general relativity of finitely old universes. So how do we now take like a survey of the models? We just imagine this enormous crowd of models in front of you, and you just have to, the mathematical models, and you have to go around with your survey. I say, is this universe infinitely old? And you sort of tick a box on either side. You're trying to sort of add it up. How do you do this? What's interesting to me is that there's the finitely old ones come in the context of these what are called singularity theorems. So the idea is that not that we look at a particular model, like a particular person, right, in our survey, but that we have a condition on a model, and if that's fulfilled, then it's finitely old. So in the oldest ones, this is what Stephen Hawking and Roger Penrose, part of what they're famous for. It's basically if the universe, if everything in the universe has attractive gravity, so everything pulls on towards everything else, there's no anti-gravity. If the universe is now I'm testing myself. Something about not allowed to have time travel, and I think there's another condition but basically, as long as gravity's pulling everything together as you go backwards in time, and you can't do weird things to loop time around on itself, you're going to have a beginning of the universe. And there's more general things. But what that's telling us is in the survey, when we have all these models in front of us, which I'm imagining like a crowd of people that we go and ask, right? What the singularity theorems do is to say, okay, that big group over there, they've all got a beginning, right? It's like an entire suburb that all votes in the same way, right? So there's a group over there. On the other hand, once you've set up a theorem like that, obviously it's got conditions, which means there's loopholes. So trying to find your way through those is interesting, mathematically interesting, physically interesting. So it's hardly surprising that physicists have looked for and found models that sort of do all the right flips and turns to go through the loopholes to land at an infinitely old universe. But those are just single people out there, right? The one person in my suburb who votes for the one party versus the other party or something. For me, the reason why I think the evidence, the clues strongly point to a beginning, is precisely because all the things that point to a beginning are the theorems, which are the big things, the big statements, this group over here, that whole suburb votes this way, right? Whereas the exceptions are specific models that sort of jump through the loophole. So the Carroll and Chen one, for example, is interesting and worth looking at. And honestly, I don't care what the motivation is. Like if they say, "Oh, we tried to make an infinitely old universe," fine, sure, right? I mean, it's a possible. If it's a solution, then let's look at it. But at the end of the day, there's all sorts of weird things in science where, like, the first person who worked out that benzene rings in chemistry, that carbon can go round in a circle on itself, that idea came to him in a dream. He just had his dream about this snake eating its own tail and then woke up and went, hey, maybe that's what benzene is. And then he was right. And you don't go, well, that's a terrible theory because the guy dreamed it up. You say, well, that idea came from somewhere. Who cares? Let's go and test it. The Carroll-Chen model, roughly, and maybe I'm sort of mixing it up with, there's an Aguirre-Grattan model, and there's a couple of other things. So I might not have the full story here. But roughly what happens is you take a universe which is collapsed. So you run our universe backwards in time, and then at some point just take our universe, flip its time axis, so to speak, right? And then just glue it on at the front. And then what would be the Big Bang before then, we'd sort of take off on another universe. It's whether you call it a bouncing model depends on what you think the arrow of time is doing through that period. But the point is that there is now, it's possible that there's a clock in our universe that's ticked forever. Or at least been around forever. This gets into weird things about the direction of time, but that's the idea. There's no point at which the universe has a sort of temporal boundary. And I think at the end of the day, you say, all right, it's possible. We're not going to get proof. It's fine that there are all these other models out there, but the best attempts we've got, the best approach we have of trying not to just look at isolated examples, but actually try and take some sort of survey to see what's going on, to see where our universe is likely to be, are the theorems. And the theorems point towards a beginning. But that's, again, we're guessing what's going to happen when the darkness lights up. So my guess into the darkness is presumably different from other people's. So I think, again, strong clues, but that's all I'll say.
Do you think that most scientists working in this area, or cosmologists, I guess, would be of the opinion that the universe probably began to exist? Is this kind of the majority view? Something close to it anyway?
It's hard to know, because the best model we have that actually predicts data, right, the standard model of cosmology, the most basic form of it does have a beginning. But the beginning doesn't do anything in terms of making the predictions. So you just imagine running our universe, just hit rewind and then go backwards in time, and it's actually expanding, but as you go backwards in time, it's contracting. And there are sort of times in the universe where if we understand what's going on there, then we would predict such and such turns out to be true. So we need to know what the matter in the universe is doing about 400,000 years after the beginning to know what the cosmic microwave background would look like. And lo and behold, there it is, and it's doing great stuff. There's light, in this background radiation. And if we know what the universe is doing, like a couple of minutes after the beginning, then we can predict the nuclear reactions that happened and how much helium there's going to be in the universe, and lo and behold, we get that one pretty right as well. But as you go earlier than that, it's funny that it's such a convenient time, but 1 second, it's a very easy thing to remember. Like, given a 13.8 billion year old universe, 1 second after the beginning. After that, we've got a model that does a pretty good job of predicting a bunch of stuff. Before then, you sort of have the chance to write your own prequel to the universe, if you like. Just imagine taking the Harry Potters and just writing your own, episode 0 before the first book. You have that opportunity because as long as you get back to the start of the first book on Privet Drive or whatever it is, the rest of the plot will unfold okay. So
sure.
I think most people, the easiest way to talk about the universe is the amount of time after the beginning. I just said it then, 1 second and a couple of minutes and 400,000 years, and we're now 13.8 billion years. It just gives us a nice time axis rather than them all being like infinity. So I think it's easiest to think of the universe with the beginning, but I think if you pushed cosmologists, a lot would come down with the I don't know, because there's a point where we'd need quantum gravity or something like that. So certainly the idea of a beginning is the most natural way of interpreting it, because that's the way most of us do most of the time.
That's a fair and diplomatic answer, and I think it's probably correct. That what I have heard often said by scientists, but popularizers of science more specifically, is that the Big Bang model tells us only that the universe was hotter and denser in the past, but it's silent about whether or not the universe actually had a beginning. I mean, is that a sleight of hand, or is that correct? that what cosmologists call the standard model isn't supposed to include the claim that there is a t equals 0.
I think that's technically correct, given that, as I said, you can write your own prequel. So, for example, the theory of cosmic inflation, whether it avoids a beginning or not, it's a prequel to the standard model. Like, it's at some very, very early time. We're talking tiny fractions of a second now. Different physics was there. The universe didn't just do what we think it would do if it was just filled with radiation and matter and all that stuff. There's something else in there that made it do amazing things in early times. We don't need the details, but basically, yes, this is why I'm saying, there are strong clues pointing in a certain way, but there's sort of a big question mark at a very early time. So, I think it certainly, you can't throw away the Big Bang Theory as it is in the standard model just because some people have a philosophical objection to a beginning. That's fine. Like, they are separable, at least. It's possible that, the universe was hot and dense in the past and then, but without having a beginning. And so you get all the predictions of standard cosmology without a beginning. Possible, but again, that would be ignoring an awful lot of clues and, of our best theory of space and time pointing in a very particular direction.
I'm glad you mentioned the model of eternal inflation as an adjustment to the standard model that might be thought to restore an eternal universe. But it's my understanding, mainly influenced by William Lane Craig, and then I did read the actual paper, that the Borde-Guth-Vilenkin theorem flatly rules out eternal inflation as a truly eternal model. Maybe there was an inflationary epoch, but that it couldn't be extrapolated to past infinity based on this theorem. What is the Borde-Guth-Vilenkin theorem, and do you think that is a correct implication of the theorem?
So, again, the way to think about this is, there's a bunch of hoops that you have to jump through if you want an infinitely old universe. And the Borde-Guth-Vilenkin, all the singularity theorems just gives you a different set of things to jump through. Sure. And so, for example, the early ones, that gravity is always attractive, we think that now that's false. We have evidence that that's false. The expansion of our universe is accelerating. So there's at least something in here that can do anti-gravity. So that's a loop that our universe itself actually jumped through. So now you start to think, okay, well, all these other theorems, does our universe jump through all of them? The Borde-Guth-Vilenkin is quite a general theorem. It's in classical space and time. So if quantum models of space and time replace that with something else entirely, then the theory just doesn't apply because it's a quantum theorem. It's not a quantum theorem. But again, we don't know what replaces it. So yeah. So basically what it says, if the universe is on average expanding, then that period of on average expansion can't be infinitely old. You just can't have a universe that on average expands forever. But there are various ways to get around that, which are fairly obvious. One of them is you have a bounce. That's how Carroll and Chen get around it. So you have before, there was an expansion period and then there's a contraction period before then. So that's completely consistent with the theory. You need some way for the universe to bounce. Interesting. Or you can have universes where there's a sort of infinitely long period of either no expansion or sort of negligible expansion. So you have a universe which sort of does almost nothing for past infinity and then starts to take off. So then when you do the average expansion in the past, you take a finite amount of expansion and you average it over an infinite amount of time, which gives you 0. If I have $5 and I have to split it between an infinite number of people, no one gets any money. So that's another way of doing it. The thing about these theorems is when you understand the theorem, you understand how to jump through the hoop. So you can make a model, you can make models that jump through the hoops. And that's an interesting thing to do as a theoretical physicist, because you want to understand what's going on, what the possibilities are. But which one's our universe, it's very interesting to me that there's not much by the way of physics that ever goes into how can a universe bounce, how can the expansion of the universe bounce. You just have to invent a new type of matter and energy that'll do that at just the right time. Possible, but who knows. And how do you have a universe which just sits there almost perfectly still from negative infinity and then sort of starts expanding in a significant way a finite amount of time ago? Again, these are just sort of... for me, it looks an awful lot like, if we go with the survey analogy, yeah, it's fair enough to say basically this whole suburb votes the same way, except for that one weirdo in house number 27, who he votes for the other side. It's the, we found the one weirdo who avoids all these theorems, but the theorem does point to an awful lot of ways that the universe is finite and leaves only a few hoops to jump through to make it infinite.
Okay. So you would agree, though, that models of eternal inflation, because they do represent the universe as in a state of cosmic expansion throughout its history, they can't be extrapolated to past infinity because of this model, because of this theory.
Yeah, I think that's a pretty straightforward implication of that theorem.
Okay.
Yeah, you can't... There was this picture of everything just inflates all the time, and every now and then, like a bubble of non-inflating stuff just forms inside an inflating background, and that forms universes like ours, which aren't inflating in the way that term is usually used. And the Borde-Guth says, no, that won't work. Try something else.
Okay, then the last question on the standard model that I wanted to ask you about is the recent discoveries from the James Webb Telescope, recent observations, which apparently indicate phenomena that are incongruent with the standard model. I think it's my understanding they seem to indicate large-scale galaxy formation a lot earlier than we would expect if the standard model were correct. What's your take on that?
So, we have to be a bit careful with the phrase standard model here, because what's actually being tested is not just the standard model of the overall way that the universe expands with time, but then the way that structure forms within it. So there is something you might call the standard model of structure formation, but it's a layer on top of, it's a sequel in my analogy, I suppose. It's a sequel on the standard model, not a prequel or anything like that. So it's so the question is, if I have a theory or a simulation about the way galaxies form, and I write that down, and then I actually go and look at the universe, and the galaxies I see aren't quite what my model predicted, something's wrong. And this is classic falsificationism, right? Something's wrong. But what part of it is wrong? And the people who have jumped to, well, this whole story's wrong, the whole standard model of cosmology is wrong, it's a bit ignorant, to be honest, because if you know the models of galaxy formation, and we've wandered right into my field, so I'm more of a galaxy formation guy than an early universe guy, just so you know. There's all sorts of messy astrophysics that goes into the actual creation of galaxies, right? So the universe as a whole is almost perfectly smooth. That's a very easy thing to model. I can do it on pencil and paper, and you get the Robinson-Walker model and the Friedmann equations. It's all lovely stuff. And then you actually want to make a collapsed galaxy, something that's self-gravitating, in which stars form when there's feedback and all this sort of stuff. So, for example, the first, the stuff floating around the universe, there's a slightly lumpy bit. The lumpy bit attracts more bits of matter to itself. At some point, you have the first thing in the universe which is gravitationally bound, where everything inside it, is strongly held up by everyone else's gravity, that the whole thing sticks together. A gravitationally bound something, okay? At this point in the universe, there's been no stars, there's no other galaxies. This is the first gravitationally bound thing. So the universe is made almost entirely, in the standard model, out of hydrogen and helium. So now what's going to actually form in there? If I collapse a bunch of matter, dark matter, ordinary matter, there'll be light and radiation, around and neutrinos and right. If I collapse that together, what actually happens? And that's actually a really hard problem because we don't have. We think stars will form, but we don't have stars in our universe which are pure hydrogen and helium. We haven't found any of those because we think that they'd be very big for various reasons, and big stars burn out really fast. And so there's just none of them around today. They all lived in the very early universe. They all burnt hydrogen and helium to carbon. They all blew that out into the carbon and other heavy elements, blew those heavy elements out, and the next generation of stars incorporated those, which changes their structure and how they form and their sizes and all sorts of things. All that's very messy, small-scale astrophysics. Right? I mean, think of cosmological scales of millions of light years. Like, a star is an extraordinarily small thing on a universe scale. So what exactly is going to happen in stars in the first galaxies that form, and how will they burn? How big will they be? How will they feed back? How will their energy and their final explosion affect the galaxy around it? These are things that people are spending their whole careers trying to answer using supercomputer simulations of early galaxy formation. I know people who are doing this stuff and have been doing it for decades. Do we know that, do we know, if we knew that process perfectly well, and there was still a problem, and we were sure we were getting the astrophysics right, then you would look at the cosmology and say, hey, maybe we've got the Big Bang wrong. But at the moment, where is the problem? The Big Bang theory, the cosmology, the background, that's the bit we know really well. We have really clean tests, observational tests of that, cosmic microwave background and light elements and all that sort of stuff. That's really good. It's this messy astrophysics of actually how galaxies form, where there's so many question marks and approximations and I don't knows that, star formation, galaxy formation, it's just a hard problem. So, yes, there are some interesting galaxies out there that we don't quite know about. What exactly is going on? Are they a bit more like disks than we thought there should be? There was a thought that they're way more massive than they should be. That's interesting. Certainly, the existence of things like supermassive black holes inside them, that's interesting. But that's what it's going to tell us about is, at the first level, is galaxy formation, not really about cosmology. So it's interesting. Stay tuned. But the idea that this is going to overthrow the Big Bang theory is just, we're not there. Maybe it's just because we're not good enough at doing astrophysics to know that actually the thing that's wrong with our models is the background space-time, not our understanding of complex galaxy, of complex astrophysics. But, in the meantime, if you're looking for a culprit, there's too many non-cosmological culprits. Actually, this is an important point in science. There's a space probe that was launched, I think, in the 70s called Pioneer. Might be 80s. I'm going to quietly just Google that off screen. It's out there somewhere in the universe, in the outer solar system. It's been noticed. 1972, 1973. There you go. It was the 70s. It's been noticed that they're now sort of 20 times further away from the sun that we are. So think of the Earth, the sun, and the Earth. They're 20 times further away, and it's moving in a slightly weird way. Right, given how it should be pulled by other planets and the sort of stuff it's going through, this spaceship is not quite moving the way we thought. And so now, as a scientist, you think, is the answer to this anomaly something interesting or something boring? Because the something boring would be, we haven't quite modelled the way that the insides of the spaceship would heat up when it's that far away from the sun, or something like that, right? A boring answer which involves us just overlooking some minor but very ordinary thing. Or is it something really exciting, right? Like some alien is pushing it out of this, that, and the other. There's all sorts of weird theories about maybe there's cosmology. Maybe like the influence of cosmology is different. Maybe we need a new theory of gravity out there. And for almost all astrophysicists who thought about this problem, there were just too many. It's not clean enough. There's just too many boring answers to get too excited about the exciting answers. And that's my rough feeling with these James Webb things. If you're like me, you love galaxy formation. It's very exciting, but it's not quite as exciting as we need to completely overthrow our cosmology. Nah, we're not there.
Right. That's a fascinating answer. And if nothing else, it makes sense to me that as this story percolates through wider media, you're not going to get as many people clicking on the link to your article if you say Discovery calls into question certain models of galaxy formation, as you are if you say Discovery's call into question the entire paradigm of modern cosmology. Scientists are losing their minds. that gets more clicks.
So we, the group at Western Sydney University where I work, all the astronomers, we get together on a Monday and someone presents a paper and someone goes through just the news, what's been in the news, in astronomy news this week. And you start seeing patterns if you read the astronomy news week after week. And there's stories which are just, I took a pretty picture of the universe, and those are great, we all love those. Hubble releases like one of those a week. And James Webb's doing that as well, great stuff. But there's Einstein was wrong kind of story, not quite weekly, but like once a month. People love to say it's the everything we thought was wrong. Everything we thought about, was right has turned out to be wrong kind of story. And it's a bit irresponsible most of the time, unfortunately. It creates this sort of boy cried wolf background of everything's a sensation, and then if something legit happens, people can't distinguish that from just the usual revolution every week in science kind of story.
Okay. Yeah, I think that makes good sense of the fanfare. And that's kind of what I suspected, but I don't know the science well enough to actually back that up. So I'm glad to hear you say that. So before we leave the topic of cosmology, I wanted to ask you the second question that naturally follows that first question of, does the universe have a beginning? So let's say that empirical evidence indicates strongly that there was a cosmic beginning in a full sense of the term, not just our patch of the observable universe, but the universe itself. Still, there's a question of whether or not a beginning of the universe could have a scientifically explicable explanation. So William Lane Craig and other theistic philosophers often contend that if we can show that the universe began to exist, well, we'll have a pretty powerful argument for a creator God on our hands. The universe would have to have a cause, and it couldn't be anything recognizably natural, so on and so forth. But there are at least a few attempts, as far as I'm aware, in modern physics and cosmology to craft a model of the origin of the universe from nothing that is apparently perfectly natural. So I think of the Hartle-Hawking model, or the related model from Alexander Vilenkin, the quantum tunneling from nothing. Don't know nearly enough about them to explain them, but what are these models, and do they successfully, even if true, do they successfully offer a natural scientific explanation of the beginning of the universe, such that there's no need to point to anything beyond the universe to bring it into being? I hope that makes sense, the question I'm getting at.
Yeah. So let's go with Hartle-Hawking. Hawking-Hartle. So what's called the no boundary condition. So there's a way of understanding the start of the universe, of sort of rewriting the story, doing your prequel, where for any clock in the universe, it can only have ticked a finite number of times. So that definition of a beginning is still holds, but there's no beginning point as such. There's no unique first moment of the universe. The picture in mind is, instead of a cone where everything sort of arrives at a point, you sort of smooth off the front of the cone, and so there's no one point which is the beginning of the universe. And the idea there is then, this is a well, it depends what you then want to say about it. the way I interpret it is, if you're just going to say the universe exists just because, then you might as well begin it this way as any other way. So this seems like a perfectly natural way of doing it. There's no singularity, there's no infinity there. There's no single point. If you had the picture of God as sort of this finger coming from outside the universe to start the universe off at a point, then it wouldn't have that. I think that's a pretty stupid picture of how you think God works, but anyway. For me, what's interesting about this is, if you're a naturalist, if you think that the universe is the only thing that exists, physical reality is all that exists, concretely at least, you just have to sort of accept that the universe is there. That at some point, all explanations stop. Even if the universe is infinitely old, it just exists. It doesn't exist for a reason, because that would be something outside the universe. That would be something separate to the universe, and there is nothing separate to the universe. Certainly nothing that has causal powers or anything like that. So actually, again, Sean Carroll, there's a very nice summary of this where he says, there's a chain of explanations which reaches the ultimate laws of nature and stops. And that's it, and you're done. So if the universe turned out to have a beginning, the job, if that was proven tomorrow, the job of the naturalist then is to try and say, well, what sort of beginning would we be fine with saying that's just the way it is? We have to say that's just the way it is about the universe anyway, so we might as well say it about a beginning of the universe. And so I think that's sort of the intuition behind Hawking Hartle, that the no boundary condition. I don't think they would put it that way, but that's the way I at least interpret it. It's if we've just got to have a universe which just is, this'll do. At least the start's rounded off nicely in a very hand wavy kind of way. It at least is not something particular, something that looks fine-tuned, although I would argue it is, but never mind. It's something that, screams out the universe isn't, the story of reality isn't done yet, which in the way that a beginning would seem to. So I think, for me, this is why, the Kalam argument, the thing it points out, the weakness in naturalism that it points out is, even if the universe exploded out of nothing yesterday, and we all saw it, you'd as a naturalist have to say, well, I guess that's the sort of thing that just happens. And that just seems bananas. That it's not that you are forced to say that about the universe, it's that's what you would have to say if there was a beginning. And if your theory has that implication of that's what you would have to say, and even if you don't know, you have to say it, right? You don't know that there's a beginning, so you're not sure whether you're backed into that corner. The fact that if you were in that corner, that's what you'd say, tells me that naturalism is sort of deficient, right? If you have to say of the whole universe, it just is, fundamentally, you're not done with reality. That's just not good enough, to be perfectly honest. So that's my take on those sorts of models. They're trying to say, I don't think it's something coming from nothing. I think that's irresponsible PR. That some people know is just PR. Some people know it's just a funny way of saying it, and some people don't know it's PR and keep treating it as if it's reality. And some people who are, I don't know what side of that Lawrence Krauss is on, but anyway, that's another story.
Oh yeah. I know what you're getting at. Lawrence Krauss is pretty famous for, at least in this niche conversation, for saying things along the lines of, we now know that nothing is something. Nothing has weight. All sorts of nonsense claims like that, where his point is that science has discovered that, quote, nothing is a thing. And it is just nonsense. It is just as much nonsense as it sounds. And it's just an abuse of language. And there's no other way to interpret it. And you have to wonder whether he's aware of this. People have tried to point it out to him.
Well, there are some little comments where it sort of gives the game away. Apparently he told an audience, this might be online somewhere, that, he's not claiming to answer the fundamental philosophical question of why there's something or nothing. He just wants to use that question as an excuse to then talk about cosmology, because that's more important. All this philosophy stuff is. So, as an excuse to stop asking these stupid philosophical questions we can't answer anyway, let's actually do some science. That's his sort of approach to it. And here's something you can find online. Of all people, Jerry Coyne, who's another sort of new atheist. He's a biologist. He wrote a book that's probably behind me, called. No, I'm not going to find it. Oh yeah, Why Evolution is True. So he's no particular friend of theism. Wrote another one about sort of faith versus fact. So very village new atheist. But he reviewed Krauss's book, which was like more than a decade ago now, on his blog. You can go find this. Basically saying, like, hang on a minute, this isn't answering the question. Why? I mean, it seems this isn't the right thing to say to this question. And someone called Lawrence Krauss turned up in the comments, and I'm leaving the possibility open that it wasn't Lawrence Krauss, because we can't tell that. Basically saying, oh, I see what you're saying, but I didn't try to answer the classical question, and so I don't think this is a valid, complaint about the book. The book, by the way...
Well, then he's misrepresenting what he's doing in the book, because surely in media appearances and in the title...
of the book, by the... Yeah, Something from Nothing. Why there is something rather than nothing. So I think if everyone understood that, it'd be all right, because no one would actually think it answers the question. So you get the more philosophically savvy physicists and cosmologists like Sean Carroll say some questions don't have an answer. It'd be nice if why is there something rather than nothing had an answer, but all the proposed answers just get us into more trouble than we started with, which is a sign that you've got a question which you shouldn't try and answer, right? If it always gets worse when you try to answer it, then give up. Which at least makes sense. So it at least takes the question seriously. But yeah, these models are just not within a million miles of that. And even Hawking saying things like, we know that because of the law of gravity, that's why the universe exists. There's something rather than nothing because of gravity or something. And it's exactly as much nonsense as it sounds like. And it's just,
so,
what do you mean?
I agree with you. So that quote, isn't he getting at the idea that the energy from gravitational attraction exactly counterbalances the positive energy of mass, so that on net the universe is net energy zero? And so in that sense, it would seem that you could have a universe from nothing because it's already on net nothing. Is that I've heard that argument before, and he does say that, but is that what he's getting at with that quote?
Well, I don't think that's what Hawking's getting at there. Part of the reason for that, so this is another thing. Krauss makes that argument early on in his book, and then by the end of the book admits that actually it's not a good argument, because we don't... Here's why it's a bad argument. We don't actually know how to do that calculation within the context of general relativity. There is no such calculation as the total energy of the universe in general relativity. Right? It's not there. You can't do it. There's no way of doing it which doesn't depend on the coordinate system, which tells you that it's not a physical quantity. It just depends on how you divide it up space-time, and so it's a coordinate-dependent thing. Okay, so it's a bad argument. Scientifically, it's a bad argument. So I don't think that's what Hawking was going at. I think he was going something more general. I think he's talking about quantum mechanics, right? Because of the law of gravity, quantum gravity, something can come from nothing, and I think it's just nonsense.
Right. I mean, I think that even the more fundamental point is that if there were such a definable quantity as the total energy of the universe, and we knew that it was net zero, that doesn't mean that something can come from nothing. A universe described with those dynamics of energy isn't the same thing as non-being. So it doesn't show that everything that exists is equivalent to nothing, and therefore it can come from nothing. I mean, that is just like freshman level philosophy 101 nonsense.
It's a bit like, if I come home and there's a brand new car in the driveway, and I say, where did this come from? And my wife says, it was free. That's not a complete... there is some aspect of this car whose numerical value is 0. That does not fully explain where the car came from.
Well, I'm on the same page with you there. So I think that was a fascinating look at cosmology, and I would be remiss if I did not grill you on the fine-tuning argument for theism, which you are well known for within this small pond. And you've written a book on it, a semi-popular introduction, which I've got right here. Let's see. A Fortunate Universe, Life in a Finely Tuned Cosmos. And it's a very good book. I recommend it to anyone who wants a deeper dive on the fine-tuning argument. And I'm not just saying that because you're sitting right there in front of me. But what is the fine-tuning argument? What is it in its whole, connecting it to theism, and what are some examples of fine-tuning?
Right, the fine-tuning argument. There's a couple of ways of getting at this, but here's one of them. The standard line from... If you're a naturalist, as we were saying a couple of minutes ago, and you are going to reach a point where you're going to say, well, that's just the way things are. That's the whole, you get to the ultimate laws of physics, the ultimate initial or boundary conditions of the universe. You just say the universe is, that's it. It has these properties, that's it, we're done. Okay? You've got to sort of, gumption yourself up. You've got to get up the internal, fortitude to say that to the universe at some point. Of saying, that's just the way it is. And no further explanations exist. Okay, now... Already you've lost me because I can't imagine saying that to the universe. But let's go a level deeper. If you're going to say that, the sort of intuition from atheists for the last couple of centuries is to say the universe not just it just is, but it doesn't have any particularly special properties. Right? If you're going to believe that something just is, it better be a sort of it would help if it were just a generic just is. It's just any old universe.
Right.
That would help a lot. It's just one way, I think, of understanding the Kalam argument, by the way. Like, it would be a major sort of... the people who have said that the universe just is, very naturally, at least 100 years ago, were saying it just is and it always has been. And so it was a bit of a poke in the eye that it looks like it always has... It doesn't look like it always has been. Anyway... What else can you do to try and work out whether the universe is the kind of place that you would be happy to say, it just is, that's all there is to it? Well, the universe we see around us on a smaller scale, just out the window, I can see trees and birds and plants and animals, and life looks not like the something we could put in a it just is kind of category, right? No way. Like... I know what it's like when I just throw some stuff together without much attention to detail, and I know what it's like to really, really carefully think something out and put it together and bring a whole bunch of all the learned skills and put it together in minute detail. And if you said, what do you think a bird is on a scale of just thrown together versus well put together by a genius, you'd say, well, clearly if someone made that, if the thing I see outside my window right now turned out to be a robot, then it was made by an absolute genius. There's no question. Okay, so life doesn't look like a just thrown together place. But let's take the argument of Richard Dawkins in Blind Watchmaker, which is again behind me. He says, yeah, look, life, he defines life as biology, sorry. Biology is the study of things that look designed. Whereas, he says, this is important, physics is the study of things that don't tempt us to design, simple things. And so, there's a way that we could be systematic about this, not just rely on our impressions, although the impression of design for life is extraordinarily strong, even Dawkins says that. When we get down to physics, we can do something more systematic. We could actually use theoretical physics to create, at least in theory, other ways the universe could have been. Other possibilities. To see whether there's something interesting going on around here or whether it's just any old universe. So, what we could do, in the spirit of let's just explore, but let's try and explore in a way where we can actually do something and not get stuck behind a bunch of theoretical physics problems we can't actually solve. Let's take the best theories of our universe we have, the standard models, which we've already talked about, standard model of cosmology, standard model of particle physics as well. Let's take those models and look at if there's anything in there that we could change in some way, that we could alter, vary, just to mess around with the universe. And it turns out there are these constants, there are numbers in there. We could try varying the form of the equations or the mathematical structures in there, but that would be much more difficult. So let's just give ourselves a problem we can actually solve. Let's vary the constants. Numbers, things like how heavy is an electron and how much matter is there in the universe compared to, say, dark matter, ordinary matter versus dark matter. These numbers. What if I change them? And if this is just any old universe, then in these other universes, we might expect them to be similar to ours. Just, some other stuff turns up. Just any old universe. That is not what happened. This is the sort of question that scientists ask for other reasons. We just are varying the parameters of our model from about the 70s, the 70s, through the 80s and continuing on. And what was discovered was really quite remarkable. If you change the constants of nature in the best physical theories we have at the moment, almost all combinations of those constants result in a universe that is just dead and boring, which can't support complexity of any conceivable kind, and in which there's just nothing interesting going on at all. So either the universe expands too far, so no two particles ever touch each other, or all the forces just can't hold anything together, so anything you make falls apart as quickly as you formed it, so you can't even have solids. Or the universe just can't form any sort of consistent complexity of any kind. This is the fine-tuning of the universe for life. It's a way that we said, all right, let's try to test this idea that the universe just is, and there's nothing else to be said. And if the universe is this just any old universe? And the answer came back, no, absolutely not. This is the remarkable life you see around you in the biological world is the result of a remarkable set of constants down at the bottom of the universe. So the sense of design, the sense of intention and purpose and genius goes all the way to the bottom of the best physical theories we currently have.
So I think that's a powerful explanation of the fact of fine-tuning, which is relatively uncontroversial. But other than just kind of the oppression, how do you more rigorously connect that fact to theism, to an argument for God's existence or a designer more generally? What's the logic here of how we go from fine-tuning to a designer?
So there's a couple of ways to try and do this. The way I've laid it out, so I've got an article called A Reasonable Little Question, which people can go and look up. It's roughly the same as the argument in the book, just a bit cool. Just a bit more sort of formalised. I think you can do it in a Bayesian way, just sort of straightforward. Here's two hypotheses. How well do they actually do in light of what we know? So I do it as a shootout between theism and naturalism. So the connection to theism is kind of these are the two things that most people are talking about. And, if people have other ideas, then we can just talk about those as well. But in terms of a straightforward shootout between those two, the deciding factor is, if you've given them both some sort of initial plausibility, maybe theism, maybe naturalism, before I consider any evidence, the prior probabilities, I haven't got a strong bias for or against either of them. What's the probability of a life-permitting universe existing on each one? And on theism, it's not absurdly small. That's all the argument needs. I don't need to say it's probable or likely or greater than 50% or anything like that. It's just not ridiculously unlikely. If you thought it was less than 1 in a million, that God would want to create a universe that had finite embodied moral agents in it, I'd say that's a weird probability. Why do you think it's so low? But I'll take 1 in a million. Who cares? Because if you say of naturalism, using this method of let's go change the constants, what's the probability of a life permitting universe? It's some absurdly small number. So the number I come up with, and you can go check it's an approximate calculation, but it's illustrative at least. 1 in 10 to the 136. is the number. So just some absurdly low probability, just ridiculous, like the sort of probability that you never go, well, I guess that could have happened. You never go, the what's the Dumb and Dumber quote. So you're telling me there's a chance, right? That's not something you do with a number that small. So that's how I'd connect it to theism, but just by making it a straight shootout between naturalism and theism. More generally, I think most people. My favourite summary of the fine-tuning argument is, I think this was Alistair McGrath. I need to actually look this up. I keep saying that. But he'd given a presentation about fine-tuning, and someone said to him afterwards, look, I'm not religious, but something weird is going on here. And that's a pretty good summary of maybe a more explicit way of doing it would be, the signature of minds is that there are more possibilities in my head than are in reality, than I actually do in my actions. So if I want to say, what am I going to do at 12 o'clock today? Well, there's a whole bunch of things I could do, but I can think through them and then select one of them, right? According to whatever purposes I have. So if there's something about the universe where it looks like the conditions in the early universe were such so that something could happen later on, the mass of the electron is like that in the early universe, not so that, it makes almost no difference back then, but so that, a billion years later, galaxies and stars and planets can form, so that 10 billion years later life can form. Then you've got something that is the signature of a mind, foresight, being able to think ahead, that the conditions here depend on, what happens now depends on my intentions for what I want to happen later. That's a sort of mind, intentionality, I think it's called. It's almost a definitional of what a mind is. So fine-tuning sort of naturally creates a push towards that sort of explanation. It looks like the conditions in our universe early on were made that way so that life would happen later on.
So, several questions for you. One is more technical from the philosophical side, looking at the logic of the fine-tuning argument. I think the way you present it, the way you initially presented it, and then the way you present it in your article that's linked below is very crisp and clear, and I've made advantage of that in a few papers of mine where I cite that as a just neat summary. It's a 4-step, simple, and logically valid argument anyway. And it's modest. It only concludes that fine-tuning is strong evidence for theism over naturalism, because in the way you frame it, you're only comparing those two hypotheses. But my question for you is that insofar as truth is not determined by popularity, like as philosophers, as physicists seeking out the true explanation for fine-tuning, we can't just consider the most popular explanations. We have to look at all of the well-defined possibilities. And so I wanted to ask, an atheist could theoretically accept your claim that fine-tuning is strong evidence for theism over naturalism, but then just suggest a third alternative explanation. And perhaps that one is, for all we know, superior to theism. And some of these sound exotic. So on the one end of the extreme, which recognizes these features of physics as a product of design, but denies that it's a supernatural designer. Again, this is really exotic, but there is at least one published paper that would argue for the simulation hypothesis as the best explanation, or at least a viable explanation for fine-tuning, that this is actually evidence that our universe is a simulation, a product of a different universe, and someone in there running some sort of experiment, either on a supercomputer or elsewhere. I mean, again, our gut reaction is to go, right. But philosophically, why? Why is that gut instinct relevant to truth? And I just wonder, even if we can show the validity of design, how do we rule out perhaps these more exotic explanations? So there's that one, which you're free to comment on or not, because it's quite strange. But more seriously, I don't know if you've had the chance to interact with Philip Goff, who is a panpsychist and prominent philosopher generally. And his view is the very poorly named, but still interesting view, agential cosmopanpsychism, that essentially the reason the universe is fine-tuned is that the universe designed itself. So there you go. Those are two alternatives that aren't naturalism specifically, but they're not theism either. So what do we say? What do we say about those?
So, given the range, one of the things I love about fine-tuning is it gets a reaction out of everyone. There's a range of reactions that I think don't get it, that just sort of miss the point entirely of the argument. Objections like, oh, but lots of our universe can't support life, so how can it be fine-tuned? Well, it's just missing the that's not the definition of fine-tuned, that why can't I live on Jupiter? Like, chill out, man. There's a bunch like that that's just missed the point, or don't understand probabilities, all that sort of stuff. And then there's the interesting ones that get it and are really trying to do something, really see the problem. I'd say the multiverse is that sort of thing. Like, you see the problem here. If your response is, what if there's infinite other universes with different properties, right? I mean, that's quite the thing to propose. You must have really seen a problem if you're proposing that sort of idea. So that's great. The simulation hypothesis, if you think that that's the solution to fine-tuning, you at least get it. You at least get that there's a problem here. And you can see, at least, as I was saying, that this problem has the shape of a thing that would be solved by a mind. It has that shape, right? I run simulations, right? And so the reason I set up the initial conditions of my simulation in a certain way is so that I get a certain result at the end, right? In some cases, sometimes I just want to know what happens. But, if I am, that is an explanation that makes sense. Why did the universe end up that way? Well, because someone thought through the possibilities and so set it up that way at the beginning. At least you've seen the mind-shaped problem that needs to be solved. So beyond that, I would suggest that fine-tuning in and of itself can't decide between theism and the simulation hypothesis. I don't think so. Maybe, so if you think there is a way of deciding between those two, it's not fine-tuning, it's something else. Now, I think there are very good arguments, but they're not the fine-tuning argument. They're just something else. Things like, I'd go in the like contingency argument. You still, why not have the mind that solves the problem of fine-tuning be the mind that solves the problem of why there's a universe at all, or any physical reality at all, rather than just pushing it back a level? Why is the simulation there? Why is that programmer there or something? And that's the conversation, but then we're not talking fine-tuning anymore, we're talking about something else. So this is why I set it up as sort of theism versus naturalism. In a sense, I think what fine-tuning really does is, if you get it, it rules out that sort of vanilla-flavoured naturalism that was just the assumed way the universe was for most of the 20th century, I would say. If you're a scientific sort of person, then you're some sort of atheist. This is just any old universe. There's nothing special going on around here. It's just any old atoms. They just clump together to make some sort of planet and lit up as a star, and then evolution just happened and life formed somehow, and we're just any old universe. That's gone. See you later. That's out of here. That proposal for the way reality is like, the sort of vanilla-flavoured naturalism, that's out of here. So the question of what happens next is then very interesting. But if all fine-tuning does, and maybe this all it does, is just push us away from that option, I think it's done a huge service. Because the other options, amongst those other options, I don't think theism looks out of place. If you've just got there's just a physical universe, it's all there is, that's all we need. Trying to sort of staple God onto the outside of the universe seems a bit weird. But if that option's out, and now you've got to think between, okay, maybe there's a simulator of our universe, maybe there's an infinite number of other universes with varying properties, maybe the cosmopanpsychism or whatever it is, maybe it's that. Like, at least we're in a very, very interesting conversation in which theism is not now like the odd one out. It's a very obvious solution. It's very good, a live player. It's not some fairy trying to join in with the scientists, right? It's the shape of this problem is mind-shaped. Why not an immaterial mind? Why not the oldest idea of a cosmic mind that mankind has ever had, a god, right, of some description? Like, we're in the conversation now. I've got to say, Goff, I'm actually going to be in Durham in where Philip Goff is in about a couple of weeks. 3 weeks? Might be a month. He's got a conference there, and I'm going to be there on cosmopanpsychism, where I'm hoping my co-author Geraint will be there as well, as the sort of the odd one out physicist trying to work out what the heck's going on around here. I can't even pretend to understand cosmopanpsychism. It does seem to me, but again, if you're making that hypothesis, you've at least seen that the problem is mind shaped. It's the sort of conundrum where we would usually say, well, some mind has to be involved here somewhere.
I think that's a largely correct view to take. I'm currently working on a paper looking at the gap problem in the context of the fine-tuning argument. So that's a name that Alexander Proust gave to that stage of the cosmological argument, where you then argue that if there's a cause or explanation of the universe, it's God. Well, there's a gap there. And so in fine-tuning, there's ostensibly a gap as well between the universe was designed and it was God. And so this is actually very helpful to think about, well, perhaps the fine-tuning argument isn't even intended to bridge that gap. It's just to get to the point, to get you to the point of recognizing that theism is a live player, and that we can't just dismiss the universe or fine-tuning as a brute fact. It's no longer going to work once you're dealing with a fine-tuned universe, or at least not nearly as plausibly.
Yeah, I think that's right. I don't think it gets us all the way, but it does knock out what would otherwise be a very live option.
So then let's discuss the leading naturalistic, the tried and true, ordinary naturalistic explanation for fine-tuning, which is the multiverse hypothesis. So in a nutshell, that would be the idea that there is a huge and probably infinite number of universes out there, all of which differ in their fundamental features randomly. These physical constants and initial conditions, they just all take on random values. And if you have a sufficiently large collection of such randomly ordered universes, then you're going to get a life-permitting combination in there somewhere eventually. And if there's an infinite number, you're guaranteed to get one. And so the multiverse by itself then explains why there is a fine-tuned universe. But then the second step of this explanation comes in. And this is quite sublime, but also obvious once you think about it. We could not have observed any other universe aside from a life-permitting one. That just follows by definition of being life-permitting. It can't house observers. And so once you recognize those two things, once you grant those two things, that there's this infinite ensemble of universes, and there will be a life-permitting universe in there somewhere, even just by chance, and this self-selection effect that we couldn't have observed any other universe, so it's unsurprising that we observe this one. The idea would then be that if you grant those 2 points, there's nothing left to explain. A fine-tuned universe is actually quite probable on the naturalistic hypothesis once we supplement it with a multiverse. So back to you, Luke. Why is this bad?
So there's a couple of things to say here. There's a gut reaction from some theists to say, oh, you just made that up to avoid God in the fine-tuning argument. And again, I want to come back to the point of, I don't care what your motivations are, I just care whether I can test your ideas. Right? All that is if it turned out your idea was wrong, I would know why you proposed a wrong idea, but I don't know whether it's wrong yet. So I don't want to do psychoanalysis, I want to do physics. Here's the thing I've been thinking about the multiverse. This is one of the things that inspired the paper that I wrote. In a sense, it slightly misses the point. So if we frame our investigation, our large-scale investigation of trying to answer this question of, look, I see a universe around me which has got some pretty amazing stuff in it. Is this just any old universe, or is there something interesting and remarkable and noteworthy and indicative of something beyond the universe going on around here? What sort of universe am I really in? And the proposal to look at the constants was just, well, let's just use the best physics we've got and see what it says. Because, we were told by Dawkins in the first chapter of Blind Watchmaker that physics is simple and it won't tempt us to design. So we're going to look at these constants. And when we do that, we find a fine-tuned universe. And then someone says, but I can explain those. It's possible that those constants can be explained by a deeper theory, right? Where the constants can change, and they do actually change from place to place. That's the whole story that you just said, the multiverse. Now, here's the thing. What that would mean is that actually the constants aren't the bottom of physics. And that question, that big question we had, we now need to go and apply it at a deeper level. We need to apply it to the multiverse itself. Whatever the deepest laws of physics is, that's where we want to apply this question, just to see where we are. And so the multiverse is really just saying, well, there could be other laws that aren't our laws that allow these numbers to change, and that would explain the constants. And the answer is yes, it would explain the constants, but would it mean that our universe is just any old universe? It's amongst an ensemble now, so it now literally is there are other universes like our universe in our local patch, but now there's a sort of multiverse. Is our multiverse any like a typical multiverse? Or do you have to do something special to get a life-permitting multiverse? Right, we just want to apply this question at the deepest and biggest scale we can to try and work it out. And here's where the problem now becomes really obvious, is that we don't have a standard model of the multiverse. We have some toy ideas about how it might work. Right? Once you've raised the multiverse, yes, you might explain the constants, but now the constants aren't the point. The point is our universe any old any old universe, any old multiverse, any old... Is there something remarkable going on around here, or is this just whatever? And we can only apply that as long as I have a good grounding in a physical theory that I can go and change the numbers in. We don't have that for the multiverse. So it's a bit like it avoids the problem rather than solving it. Right? It might sound strange to say in terms of the fine-tuning, but the constants were only ever... The intuition that the fine-tuning argument relies on, the constants were only ever our best chance to get a handle on other possible universes. So saying that, maybe they're not the best handle, maybe there's deeper physics, is sure, but until that comes along, we're gonna keep investigating the best handle we've got. Great, you can imagine a scenario where our universe looks sort of typical out of an ensemble of universes. Fine. Is that actually true? And does a multiverse itself need to be fine-tuned? And that's at the point you realize that we can't answer that question. Either you give up on the big question, is this just any old universe? Or you say, well, until a better theory comes along, we should just stick with the best physics we've got, which is fine-tuning. Which displays fine-tuning. So my answer to the multiverse is really, I think it misses the point. Like the varying the constants was only ever a means to an end of exploring other possibilities, and explaining those with a multiverse, sure, but we still want to explore those other possibilities, which now go out to sort of other multiverses, but we've lost the ability to explore them now because we don't have a theory of the multiverse. So I think that's the sort of where I'm at the moment. Given the question we're trying to ask, our best chance of answering it at the moment is the fine-tuning of the universe for life. And the multiverse is just a mere possibility. That's all it is. It's just a cheap... the toy models. It's just it's just mere happenstance. It's just, who cares?
Well, I'm not so sure about that. I mean, I think that we have to be careful about the context within which we are discussing fine-tuning. If we're doing science, then I think most of those complaints are pertinent. There's no well-developed scientific theory of the multiverse or underlying physics that then imply that there is a multiverse or predict a multiverse. But the fine-tuning argument is a philosophical argument. And I mean, we can know that because theism isn't advanced as a scientific theory. It's advanced as a metaphysical proposal. And so it's just it wouldn't be a complaint to theism as an explanation for fine-tuning to say, well, you've given no further explanation about the way in which God fine-tunes the universe, or the internal dynamics of God's power and how he does these things. It's not offered as an empirical or scientific explanation. But insofar as then we are in this philosophical context, the naturalist offers the multiverse hypothesis as a possible explanation on equal footing, ostensibly, with theism. And so if we want to say that fine-tuning is evidence for theism, we have to rule this hypothesis out or give some reason to think that it's unlikely. Because I think what the naturalist could say to you when you said, this is just offered as a bare possibility. Well, they would say, theism is just offered as a bare possibility, blah, 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 blah. Because I guess if there is a multiverse and some deeper physics that accounts for it that are currently beyond our ken, at least for the naturalist, we've now moved the question of the specialness of our universe to one of agnosticism. We would say, well, we just don't know yet because we can't test the physics of the multiverse. But that wouldn't be to say that we have any reason to think that it would turn out to be special once that further physics comes into view. So there's a range of responses there, but I guess what I'm getting at is that it doesn't seem like a legitimate complaint in a philosophical context to say, well, we don't have a scientific theory of the multiverse. Well, we don't have a scientific theory of God, so how pertinent is it?
Yeah, that's good. Let's think through that for a second. So first of all, the question, have you provided enough details for us to answer this question? I think it's a part of the argument is the probability of a life-permitting universe on theism is not ridiculously small. That's got to be part of the argument. So you do have to say something about God and what's likely given theism and all that sort of stuff. The reason I think the argument has some intuitive traction is because it doesn't seem like you've got to make ridiculously precise assumptions about God in order to say, well, I suppose it's not that unlikely that a finite good mind would want to make, an infinite good mind would want to make a universe in which there were finite minds capable of moral action. Right? The infinite mind creating finite minds just doesn't seem that unlikely to me. So I think the question of, you haven't got a mechanism, you haven't got a mechanism for God. The thing to say about that is, no, God's not a mechanism. I mean, there is no mechanism. What there are with God, because God's a mind, is reasons. And what we have got is a glimpse, at least, of a pretty plausible reason of an infinite mind creating the conditions necessary for finite minds. It's just not, I don't have to say, there's no specificity in there for 100 decimal places, and then God would make a universe capable of supporting minds. So I don't think that's the comparison to make. The point with the multiverse is that, okay, if it depends what the naturalist is trying to do. If you're trying to say, well, we don't know whether this is just any old universe because we don't know whether the multiverse exists or not, you've actually slightly missed it again. Because if we had a multiverse hypothesis, what we would want to do is what we've done with the standard models, right? I get in there and I turn all the knobs and dials and I do simulations and calculations. We try to put the way we think our universe is in context of a bunch of other ways the universe could have been. So if we drop down to, there's a multiverse and we actually know how it works, now we do that same question. It's not about how the way the universe is, but the way it is relative to how it could have been. So I want to take the multiverse and consider other ways the multiverse could have been. Now, the naturalist might say, because we can't do that, because that's a possible way the universe could have been, we can't know whether our universe is sort of typical or boring or needs a mind or something like that. And there's two things to say to that. The first is that it's the shape of a whole bunch of arguments against God that they think they can say what the universe would or wouldn't have been like if God exists. Right? I mean, this sort of, if I'm, maybe this is the point of the fine-tuning argument. If you make that move against the fine-tuning argument, you can't make an objection if I use a similar move like skeptical theism against the problem of evil. So maybe worst case scenario, like fine-tuning problem of evil, just cancel each other out, and we're we're off on, they just annihilate each other is the best argument from both sides, and we're back to square one. Maybe that's maybe that's where we're at. That would be kind of amazing. But more generally, I think we're justified in saying, look, you've said, atheists, for the last 100 years, this is just any old universe. You can't complain now if I use the best physics we have to test that idea. You can't then say, oh, but there could be physics in which we're just any old universe. If I've pushed you into that corner, there could be, it's not the physics we know, but there could be physics in which it turns out, against every indication we have otherwise, that our universe doesn't have the sort of signature of design on it. If you're pushed into that corner, that's more or less an admission that the fine-tuning argument's a good argument. It's not a proof, but, this is not the, Bertrand Russell were just an accidental collocation of atoms, right? If I've pushed you out of that bold statement into a corner where you're like, well, maybe there's lots of other universes and will turn out to be boring and unexceptional amongst all this physics that no one has the slightest clue about. I think the fine-tuning argument should only ever claim to be, let's take stock of where we are. And I think that's legit because that's the sort of basis under which theism has been attacked for the last 100 years. Look, we took stock of where we are. We're in the middle of nowhere around some minor star on the outskirts of some galaxy, and we're just the end products of evolution. There's nothing interesting going on here. So if fine-tuning hits back against that and says, actually, no, the design we see around us goes all the way to the bottom, if the atheist wants to then retreat from that and say, well, okay, look, all the science we have points towards design, but possibly future, as yet unknown science doesn't point that way, then, that for my mind is just admitting that this is a good argument. It's not conclusive, but, here we are. You can't claim that I'm going against science and you're going with it if you have to rely on as yet unknown science to save your position. That turned into more rhetoric than logic, but
No. Food for thought. I'll have to think about that as I contemplate fine tuning. It's the central research area that I'm focused on is fine tuning and the fine tuning argument, and trying to advance the lesser discussed aspects of the debate. And so, I don't know if you found this. I find, zooming out for a minute, that the fine tuning argument is utterly fascinating in so many different ways. And that it's kind of like this endless source of scientific and philosophical reflection. It pulls together so many different interesting issues and questions.
Yeah. Around about the time that I started reading papers about counterfactuals, because I realized I was saying, the way the universe could have been. And that's something you just say in everyday life. Like, you don't think about that. And then the philosophers, you're like, yeah, there's like a couple of centuries of people trying to work out what that sentence, what that construction, like the counterfactual construction, what that actually means metaphysically.
Yes.
Like, okay, let's go down this rabbit hole for a while. But yeah, probability theory, the role of symmetries in physics, just everything. All the stuff I'm interested in just lands in the same place. Wonderful stuff.
Yeah, I feel the exact same way. It was my master's dissertation, and now hopefully, as I apply for PhDs in December, the subject of my PhD level research. But as we round out, I thought I would ask you a bigger picture question about fine-tuning in general and our efforts as a human species to explain the fundamental facts about physics and the universe. It seems to me that when we ask the question, what is the best explanation for fine-tuning, we're inevitably going to be entering an interdisciplinary topic and conversation, and that it will involve both physicists and philosophers in the attempt to find an answer. But it's not always clear where to relegate the relevant parts of that discussion and what parts are philosophical and what parts are scientific. Because I think we touched on this when I said that the fine-tuning argument was itself a piece of philosophy rather than science, and that theism isn't offered as a scientific explanation. But Physicists and cosmologists, as far as I'm aware, are attempting to explain the fine-tuned features of our universe. They want to know what the ultimate explanation for that fact is. And if we grant that it's theism, zeroing in on the possible world where it is theism that explains fine-tuning, do you think that God should enter professional journals of physics and cosmology for that reason? Or what would you say to those cosmologists going down the rabbit trail of natural explanations that will have no end? I mean, you know that in this possible world. I feel like fine-tuning puts stress on these neat distinctions that we want to draw between what is properly natural science and what is properly theology and philosophy. Given that there are very serious possibilities that theism is an explanation for this, what do you as a scientist see as the proper role of the scientist, and where does that end and the philosopher's input begin?
So I think the way that I've been trying to lay out the argument, if it's a let's take stock of where we are argument, I'm not trying to insert God in the middle of science. I'm trying to say, look, if you've properly understood something like naturalism, and you say with Sean Carroll, there is a chain of explanations that leads to the ultimate laws of nature and stops. It's then, some people say that God is a science stopper, and naturalism is a science stopper, because there has to be a stop somewhere. I mean, well, I suppose there could be just infinite layers of laws, one below another, but that would be a science stopper. I mean, that would be just horrific. As a physicist, like, oh no, like an infinitely large crossword or something. So the fact that, look, I mean, we've both got, so both Sean Carroll and I believe that in terms of physics, there is a chain of explanations that leads to the ultimate laws of nature and stops. For Sean, that's the end of all explanations, and reality is done, right? You get there, that's it. For me, we're not done, right? There's a reason why the laws are that way rather than some other way. But we both will do the same science. We both want to get down to what those laws are, and we both want to know how they play out in the universe. And I think, it shouldn't be a sort of a secret behind the argument. It should be a sort of laid straight out the front. The fine-tuning argument is not claiming that the laws we have at the moment are the deepest laws we're ever going to find. It's a taking stock of where we are right now kind of argument. And if new science, new laws come along tomorrow, then we'll look at those and see whether the best candidate we have for a stopping point looks like the sort of stopping point where you'd say, that'll do, we'll just have naturalism and that'll be fine with Sean, or with the sort of stopping point where I would say, come on, man, look, that this has a mind-shaped hole. Like, if you put a mind behind this, it would explain an awful lot about why it's this way rather than some other way. And the best we can do with trying to work out those two is just taking stock of where we are right now. It's all, I can't take account of physics we don't have. But I'm not, if it changes tomorrow, it changes tomorrow. Fine, right? I'm just taking stock of where we are. So at no point do I want to say, I know that this constant has this value because God said it that way, and that's all there is to it. In fact, I think that's rather unlikely. I wouldn't be surprised if God had a more elegant way of setting up the universe than just laying down constants with a particular value. So if there is some sort of deep symmetry behind the universe, I think that there'll be a great fine-tuning argument there as well. I just wouldn't be surprised if God's found a cleverer way of doing it than that. Maybe not. But from us, from the inside, taking stock of where we are, I think the fine-tuning argument's the best chance we have of saying, look, if I was staring at the ultimate laws of nature, would I be fine with just that being the whole of reality, or would I want a deeper explanation than a physics explanation? And I think fine-tuning points to that mind-shaped hole in physics.
Okay. I think that is a powerful place to end. I always ask this at the end of interviews, discussions. just for formality's sake, did you, Luke, have any questions for me?
Where are you thinking of applying? I now want to know what you're going to do for the PhD. Where are you thinking of applying, and what aspect are you thinking of looking into?
So I'm going to apply to 8 places, it looks like. Applications start, the due dates begin 2 months from now, so I have to finalize everything pretty quickly. As for like which aspects of the argument, so far it's just being dictated by paper by paper what I'm finding interesting. So I did my dissertation and looked at Neil Manson's objections based around divine psychology. You read that paper, which I was very grateful for. I'm working on right now a very complicated topic, and I'm struggling to synthesize it, about the inverse gambler's fallacy and whether or not the multiverse hypothesis commits it in explaining fine-tuning and adjacent issues.
This universe objection, is that one?
Yep.
Or is that something else? Yeah.
Yep.
I still don't get that objection. I just doesn't. Philip Goff, I'll talk to him in a month about it, but he thinks that's definitive and decisive, and I just
He does.
I mean, the word... Oh, yeah, we're getting off topic. The word this... No, it's actually right on topic, but I'm opening a huge can of worms. The word this means the thing I'm pointing at, right? I mean, this, you know, that's a shorthand for that, you know, this thing I'm pointing at right now. And so I don't know what, you know, when you start saying this universe, except that I varied all the constants, what are you doing? I just don't get it. Anyway, if someone could explain that to me, that would make a whole lot of sense. I'll be annoying Philip about that soon, hopefully.
Yes, and I was going to say soon enough there'll be a brilliant synoptic summary of the relevant research published shortly by me.
Excellent. Right up my alley. Send it along.
Absolutely. Well, Luke Barnes, this was a fascinating conversation, and I'm confident that many people will get a lot out of it. So thank you for coming on the channel today.
Thank you for having me.